basic experimental methods need to be discussed in detail, because the essence of experimental problem in reaction kinetics is to devise a proper analytical technique which will enable the concentrations of the reactants or products to be found at any time during the course of the reaction. There are some considerations which will help us to devise proper techniques. We know that rates of reactions vary with the temperature. Therefore, it is necessary to maintain the temperature constant during the investigation. That means we have to carry out the reactions in a thermostat, and the accuracy with which the temperature is to be controlled should be within 0.1 degree centigrade. Use standard calibrated thermometers to measure temperature. It is also necessary that the reactants must be maintained at the bath temperature before mixing. Otherwise, to equilibrate to the bath temperature, reactants will take time, during which time their temperature is much lower. Mixing should be rapid and thorough, so that the mixing time is kept to a minimum. Aliquot should be withdrawn immediately before the clock is started, which is our zero time. In some reactions, we may have to work at high temperatures. In such a case, expansion of the solvent may lead to errors. The reactions should be carried out in sealed tubes. The aliquot that is withdrawn from the reaction mixture should be frozen. That means we have to cool it down. Here we take the advantage of slowing down of reactions at lower temperatures. The cooling can be done by pouring ice cold water or by adding a reagent which selectively removes the reactant, or at least decreases its concentration to very low levels, thereby almost stopping the reaction. We need to have a good stopwatch to measure the time. That means how one experimentally determines the rate of a chemical reaction becomes the very important question, and we need to answer it accurately. So, measurement techniques are of two types. One, the chemical methods. Second, the physical methods. As the name implies, chemical methods in kinetic studies rely on chemical processing to determine the progress of the reaction with respect to time. These methods are generally cumbersome to use and are limited to reactions that occur on a slow time scale. Majority of modern kinetic experiments involve physical methods in which a physical property is measured as the reaction proceeds. For some reactions, the system pressure or volume provides a convenient property for monitoring the progress of the reaction. One example we can consider is thermal decomposition of PCl5. PCl5 decomposes to give PCl3 plus Cl2. As the reaction progresses, for every molecule of PCl5 that decomposes, two gaseous product molecules are formed. Hence, the total system pressure increases as the reaction proceeds. Measurement of the increase in pressure as a function of time provides information on reaction kinetics. But the chemical method, as we said, is based on titration or volumetric analysis. A known volume of the reaction mixture is removed at various times and rapidly cooled by adding ice cold water, which hopefully effectively stops or slows down the reaction considerably. The concentration of one of the reactants now determined by a suitable titration. Now, withdrawal of the reaction mixture, we can do it by pipetting out the mixture into ice cold water directly. We may have to add an indicator as and when required for the titration. Take the example, if you have acid catalyzed hydrolysis of methyl acetate, we can follow this reaction by titrating the reaction mixture against standard alkali. So, this is the reaction, ester undergoing hydrolysis in presence of an acid to give you acid, that is acetic acid and methanol. As the reaction progresses, the concentration of the acid increases, which can be suitably found out by titrating against standard alkali. The data generated can then be used for finding out the rate constant and further the order of reaction.